Have we got any questions for this afternoon's panel?
Sorry.
Yes, over there.
Two round.
Sorry.
It's a question for Christopher. I just wondered if you could talk us through some of the kind of planning approval issues around carports and car parking. With local authorities, a lot of the time, is it planning authorities giving permission to themselves, or for other types of owners? What are the planning issues?
Local authorities giving planning permission for themselves, I won't go anywhere near that. I'm sure they do it all above board. Generally, it's perceived as a good thing. There's planning permission obtained for a solar carport in the site of scientific special interest, a bird sanctuary. So one can say if you can do it there, you can do it anywhere. But it's the whole concept. Solar farms take up arable land and potential residential spaces. Building essentially solar farms on car parks is a good use of land. It's a dual use. There's no change of use of the car park. So in planning language, that means go ahead. Is my generally a bullish answer to that.
Any other questions? I've got one of my own for Simon. You mentioned you've got 500 systems-ish deployed at the moment, but you talked about the figure of about 10,000 as, you know, to obviously the larger the better, the greater the number the better. What do you see would help you get to that sort of number? Where do you see that going, and what sort of stimulus would you need?
So we're seeing a trajectory to scenarios where hundreds of thousands or maybe a million type systems are deployed in the UK by 2020. Now, it's really three markets. There's an early adopter retrofit to existing solar, so targeting the 800,000 people who've already got solar with a seller, and that's put through the fit administrators or through the solar installers, and it's quite a crisp market. Now, some of the motivations in that group are early adopter or self-consumption or green, so it's a mixed motive, not 100% economic. Bear in mind, people bought solar on a non-economic motive and then various degradations of fit. The more interesting market is these social housing projects to take the sort of original solar pipeline, which had solar, but do solar plus storage, which means you can grid shift to an evening or to arbitrage or to a business model. And they're quite tight on the economics, but again, different motives across social housing, maybe to use spare fit income or efficiency or carbon. And so depending on the location, those projects can make commercial sense now. They're a bit harder to do because there's lots of sort of experience needed on metering and install and reducing the total system cost. The government, by stepping out, has been helpful because storage has never had any incentive here. So and fit reducing helps storage. So actually, by not getting in the way, is quite helpful. It would be nice if there were a free present, but there isn't, and we're not banking on any. And the regulation is quite light for grid edge because you don't need planning permission or environmentals. And so no one really stops you. The issue is more about contracting all the multiple parties and stacking income, getting the best value out of that. So there's more down to the contracts by National Grid or the network operator guidelines for deferring capital or giving GAT3. So some transparency guidelines and more reference models and more actual deployments would help. I think then what happens in time is the market of white labeling product with utilities becomes very interesting post smart metering and the DCC being live. So post 2018, when more people have smart metering and it's easier to opt into a special tariff, then the market's very interesting. Peak charges are going to be bigger. They're going to be passed on to customer. The utilities need smart metering in order to offer, read the meter differently, offer more bespoke products. So I think then you get a mass market scale. I think I say to summarise, I think some clarity guidelines would help, more reference models, a bit of leniency in the financing, so it's not trying to sort of make as much money as possible out of the financing in a yieldco. Storage is a bit young, and so you can't deliver the returns day zero. Being flexible to the fact that this is an asset which is going to grow in income. The Brexit stuff is kind of indirectly helpful to storage because prices go up for retail energy, electricity, oil, gas goes up, volatility goes up. Europe owns all our energy, and so we're nice to them, and that's helpful. But storage effectively helps mitigate some of these things, even though it creates a lot of uncertainty. Retail energy prices will go up. We know a number of new suppliers who are going to exit the market in the next 3 months because of the volatility, and storage is a way to mitigate volatility.
Excellent, thank you. Any other questions from the audience? Yes. Save me thinking of more.
Thank you. Sorry, it's a question for you, Simon, again. It was just really about the cost of a system for an individual householder, and if you sort of looked at the payback, and I'm assuming it's available to the individual householder, but yes.
Yes, so if you want to buy one, they're available from meetmaslow.com or from Edmondson or a range of distributors. Whilst we have some B2C, they're generally through distributors or installers from around 2,200 a system, which is a 2 kilowatt hour all-in-one battery plus inverter plus power electronics. 3 kilowatt hours is a bit more. Strategically, we want that price to halve by volume production and also pre-financing some of the income. The battery is an asset to you as a household and an asset to the system. We may use asset finance to reduce it. So, but around £1,000 for a kilowatt hour all-in-one system per kilowatt hour. That will drop to €1,000 to $1,000 and then to free. So there's a trajectory over the next 36 months where these products become cheaper to an individual household. So you buy your bit of it rather than buying the whole system and getting cash back from an income service. So today is about a 10-year payback, but it should be 7, then 5, and then included in your energy deal. So I think that's in line with kind of the next 48 months. And energy prices are about to rise in stages. And I suppose what's interesting is whilst customers were aware of solar being a sub-10-year payback, it's now much north of 10 years. So after sort of now people are beginning to understand that things nearer 10 years are okay. Whereas if you went in last year and said, here's a solar storage product for 10-year payback, people would think next year. So now actually it's much, much better than solar in isolation.
Yeah.
The lifespan.
So lifespans vary by chemistry, except if you join a grid service, it's aligned to the...
Specifically, you say that is 2 kilowatt.
Ours is a 10,000 cycle battery, so it's actually we'll replace the battery effectively for free if you're in a grid service contract, so it will be a perennial, because we're incentivized to make sure your battery is a part of our grid cloud and pay your money. So unlike a washing machine warranty, or I want to sell another washing machine, I want your system asset to be maintained, so I'll probably upgrade your asset over a period of time. Chemistries today range from sort of like 2 years to 20-year cycles. So if you put a Konschill in, which is a Swiss chemistry, it's like north of €1,000 a kilowatt for just the chemistry, without the system, without the install, and it's reinsured. Except it's a very expensive asset in 5 years' time when batteries are $100. So typically batteries are around $400 in chemistry, on a trajectory down to $100. The power electronics is on sort of $100 to $300 on a trajectory. The O&M, so it's like LED PFI. If you buy an asset today, it looks great on a business plan, but in 5 years' time, it might look stupid if you're paying $30 for a light bulb. So we have that concern on battery chemistries in the sense that a middle road chemistry like lithium FePO4 or some lithium ion is okay in the short term, but on carbon, sodium might be better in a few years' time. And there's a whole bunch of new chemistries on a 5-year out trajectory. And so to put in a 20-year decision today, we don't think is the right answer. 5 or 10 years is the right answer, and then replace it. Tesla has a model. If you buy a 10-megawatt farm from Tesla, you give them 2 tennis courts. One of them is full up with batteries, and you give them the keys, and they update the rest of the tennis court over the 10 years to make sure it's a 10-megawatt output. Doesn't mean the chemistry lasts 10 years, but the PPA contract does. So then it goes back to, do you trust the provider? Are they insured or not? But chemistry, in our view, actually isn't the problem on term. It's actually software, O&M, those kind of things. If you think through broadband in a house, how many routers did you go through to get to today's broadband router? How many gateways will you go through? How many smart meters will you go through? How many thermostats will you go through? So we think like boilers. Boilers are there for a decade. Storage needs to be for their decade plus. Thermostat, so it's quite thinking through persistency for domestic is quite important, and to try to make it look like solar today is the wrong answer.
Any other questions? Oh, a few.
Yeah, question for Dan. You mentioned that one of your latest solar installations that rather than offering a PPA, you've gone down a service charge route. Is that something you think is going to be more interesting to people where maybe your clients have been used to signing up to long-term service charges in the past, whereas trying to ask them to sign to a long-term power purchase is probably is something newer to them? Are they more comfortable in doing something like that?
We've probably slightly misunderstood. So we actually own the assets. So the service charges to our occupiers of the actual building. So the service charge is there throughout the lifetime of the building. It covers all sorts of aspects. Obviously, energy is included in that, and effectively all we're doing is reducing the cost that they'd be paying. They'd be paying if they went out on the market, as I said, 10, 12p, and we're able to charge it less than that back through the service charge. So it's fairly easy to do. It's well received because effectively it's just less on the service charge. So it's definitely something, as I mentioned earlier, something we'll continue to do. And it's easier than going down the route of where we have a sole occupier with one of our assets, because then they have responsibility for the roof and it gets a bit more complicated. Where in a typical office building, it's simpler to do.
Seema, gentleman in the middle there.
Yeah, hi, Stephen from Catalyst. A question for Irene. I just wondered if you had any figures on costings for the BIPV in terms of any premium above, say, non-PV glazing, or whether you've got a full cost-benefit analysis in terms of looking at both the PV installation and glazing together.
So in the specific case study for St. Bartholomew School, it was more or less a break even. It would have been a lot more money actually to achieve the BREEAM credits if you wouldn't have gone for the BIPV. Because we had already gone down the venue of achieving all the possible credits we could any other way, and therefore the BIPV then ticked all the remaining boxes and did that in its most efficient way. So if you would have just gone for normal solar control glass, we may have saved. I mean, it's a very small installation actually. It's just a 3 kilowatt installation because it was just a small extension, but we might have saved £4,000 or £5,000. But then in actual fact, to get the BREEAM credits for that on a £1 million extension, it would have cost us a lot more money. So it was actually negative in this case. It was a real performance. I think the issue with BIPV is always the red herring, obviously, for everybody involved. And the frustrating thing about BIPV is we can't give any sort of generic answers because BIPV is truly customized. So what we always say is please contact us and we will make a case study with you together, like we did for Sainsbury's at the time. I mean, with Sainsbury's at the time, if you take into account the staff saving, the staff cost savings, you can actually get a payback within 5 years. If they re-roof and reglaze all the roof lights and integrate it into the facade, because of the all additional knock-on effects on the building services costs, but also the staff performance. And then once again, the staff performance is still quite a soft target. On the one side, it's proven, but on the other side, on the other hand, a lot of people will still not take that as a real hard target. So it's difficult. I think it needs to be resolved with on a case-by-case basis, but particularly with building types like the education sector where real targets are required, like the BREEAM ratings, it's always a winner.
Gentleman right at the back there, Seema, please.
Hi, you heard a Lethbridge from, what was DEC. Sorry, question for Christopher, if I may. Have you looked at, not necessarily instead of, but in conjunction with having charging electric vehicles, also generating hydrogen on site for fuel cell vehicles? Obviously, if there was a sufficient demand for hydrogen, would that be as profitable or more profitable than just generating electricity and storing electricity for whenever someone wants to charge up their cars? Thanks.
Who was that for? Who were you asking the question to?
To you.
Oh, okay.
Sorry. I thought I said that.
I was hoping you weren't asking me there. So hydrogen economy is not an area of our specialism. So I do open that up to the rest of the panel to embarrass themselves with their ignorance. Generally, your question is, could you essentially convert the electricity and store it as hydrogen instead of storing it in batteries? Technically, yes. The question is it cost effective? Don't know. So I open that up to anyone else.
Anybody else care to have a go at that one? No. Okay. Any other questions? Just one from me to Dan and John. I didn't introduce you from Syzygy.
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 It's easy when you've had a drink.
Which I plan to do later. Yeah, Dan, you mentioned, or you implied obviously, that from a tenant or attracting new tenants or tenant retention is certainly helpful when you're reducing sort of carbon footprint or the running costs. Have you got any specific examples? How attractive can you quantify that in some way? It's something we often talk about, but is there any way we can quantify that at all?
It's not quantifiable. It would be good if it was.
Yeah.
And it might be at some point in the future. It's fairly intangible. We had a conversation earlier over coffee, and I was saying, typically, I think when we have panels on the roof, it seems to be more powerful as a retention mechanism for an existing building with an existing tenant to make them consider renewing their lease than it might be to attract a new occupier. I think it just gets almost lost in the noise when you're looking to attract a new occupier. But I think engaging with existing tenants and as part of their renewal exercise, I think it's quite powerful to be able to say, well, we might be able to remove a lease break, or we might be able to look at different opportunities to provide our energy. I think then it does add real value, but it is at the moment fairly intangible. John, have you got any thoughts or tangible numbers?
So again, not many people know me here. I run a renewable energy consultancy, and we kind of focus on the industrial and commercial property sector, advising occupiers and landlords on what they can do with their assets to generate energy. But a big part of what we do is tie that into the property strategy. So we kind of marry the technical with the commercial. And I guess the first point is about vacant buildings. In fact, there's a picture, I think, on the back of the one with the aeroplane on the back of the brochure, which someone showed me earlier, which is Seagrow building. So Terry, who was here earlier, that was vacant. It's at the end of the runway in Terminal 4. That was vacant, and it was a test really for them. It'd been vacant, bit of a white elephant. It's a 2-story industrial building built at the top of the market, kind of model on sort of things you see in Japan and places like that, and they really struggled to let it. And they effectively have connected them all into the individual units, and they're not charging the energy. It's just a kind of, look, there's 50 kilowatts in each of them, and you can have it, if you move in. They did let quite quickly, and the tenants are using all the energy. We monitor it. I don't think it was the only decision, but I think it didn't do any harm. And when you're looking at it, we're doing quite a lot of work for a company called Prologis, who are a biggest logistics developer in the world. And for planning, often people for new buildings have a planning requirement to put on to meet 10%, 20%, depending where you are in the country. In Tower Hamlets, it's 45% of your forecast energy consumption with renewables. Quite often, because of the sort of fudging that goes on to make it look like a very, this is only going to be used for ambient storage. There'll just be some, small amount of lighting. It means you don't have to put very much solar PV on it. It's kind of window dressing. So for planning, it's not particularly onerous. But actually what Prologis are doing is they're saying, well, look, forget about what we're doing for planning. We want to put on, a load more to our buildings, because we believe that when we go to market, they're building these all speculatively. They don't have occupiers in mind or lined up. Their view is that they, if they've got say 400 or 500 kilowatts on a roof, in very broad terms, that's £50,000 a year worth of energy. but it'll be a 200,000 square foot building letting at £6 a foot. That's £1.2 million a year, 100 grand a month. If they let that 2 months earlier, well, that's £200,000 effectively knocked off the price. If you know, of their 500 kilowatt system, if you're thinking about sort of netting it off. So their view is, we think, you know, and if you think about the aggregate value of that energy over a 10-year lease, you know, the equivalent to a rent-free for an occupier is actually quite considerable. So people are sort of looking at things differently now. But there isn't any, at the moment, any hard evidence. Someone's saying, you know, you will let your, and I don't think we ever will have a, you will let your building 3 months quicker if you're, you know, giving them an element of free energy. But it can't do any harm. And our advice is always, you know, you need to put more on, not less, in order to make a difference. If you're putting 4 or 5 kilowatts on a 20,000 square foot shed, I don't think anyone really, you know, makes any difference at all. So that was the first one. What was the second one? Oh, about kind of lease renewals and existing occupiers. Yeah. Well, that's the same sort of thing. It's the same calculation. 500 kilowatts, £50,000 a year in year one, depending on what you think is going to happen to energy prices. You know, we've all got our views. We typically use 4 to 5% as a sort of inflator, and you're getting to £700,000 or £800,000 worth of energy over 10 years. And that is a considerable amount of money. And when you've got an occupier who comes to the end of a 10-year lease and they're getting that, it could be, you know, £90,000 worth of energy a year when they come to renew their lease. So anywhere else they go, they're going to have to, it's going to cost them another 90 grand a year. And you capitalise that, it has quite a big impact, we think, on retaining occupiers.
Excellent, thank you. Yes.
Just as a shameless plug, linking back to that, if you look on bream.com, there are some case studies and reports that we've produced about the cost savings and payback associated with Bream. Funny you mentioned Prologis, because they're one of the people who are using Bream a lot, and that's exactly the reason. So it's slightly wider than just the PV, but the sustainability message in general is retaining tenants and people using it for that.
There's also, if I could just chip in, there's also no question that occupiers are looking really hard at operational costs. That's not just whether they save some money from solar, it's, you know, how well built is the building from an energy efficiency point of view. All of this stuff, it goes into the pot when they're making decisions. And, you know, BREEAM ratings, you know, have always been important, but they seem to be much more important now. You know, I think we're doing a project that's about to be the first, you'll probably tell me there's another one, first zero carbon industrial building. You know, solar is just one little bit of that. And I think, you know, bigger occupiers, national companies, that's making a huge difference to them now. So they're putting pressure on landlords. COP21 has put pressure on, you know, the large property companies. It's hit the chief executives' desks now, which is kind of a bit of a relief, really, as the tariff cuts came in. In some respects, it's not, you know, in some respects it's good because it's now not purely a financial thing. It's forcing people to consider the wider benefits, why we're all actually doing this. But thankfully, COP21 did just come in as we were thinking, how are we going to persuade, you know, our less enlightened clients, you know, as to why they should be doing these things.
Excellent. Thank you. Well, if there's no further questions, I think I'll probably wrap up for the day. I started off saying how long I've been in the industry, but never a day goes by that I don't learn something new, and I think it's great to say I've certainly learned plenty today. So, which is one of the reasons I love this industry. But mainly, I'd like to thank our presenters for helping us. I hope you've learned something new as well. So.